Hey everyone, welcome back to my YouTube channel. In my previous video, we had an introduction of SwiftUI and its basic components. In my today's video, we will be discussing about data flow in SwiftUI. Understanding how data moves through your SwiftUI app is essential for creating dynamic and responsive user interfaces. So let's get started. In SwiftUI, data flow is all about how data is passed and updated within your app's user interface. It's a fundamental concept that ensures your UI stays in sync with your app's data. There are 6 main ways to manage data flow in SwiftUI: state, binding, state object, observed object, published, and environment object. I'll explain each one in a simple way so you can see how they work. First up, we have state. State is used to manage state within a view. It's perfect for simple state management needs. When you declare a property with add state, SwiftUI automatically monitors it for changes. When the state changes, SwiftUI will re-render the view to reflect the new state. Let's see an example. Let's create a new variable. Let's call it counter. Let's remove the placeholder text and create a simple text. So in this block of code, we are simply showing the value of our counter. Now let's create another button. Give it a title of increment. And add an action to it. That will simply increase the value of this counter. Now refresh your canvas. In this example, we have a counter that increments each time the button is pressed. The state property ensures that the UI updates accordingly. Next, we have binding. Binding is used to create a two-way connection between a parent and child view. It's useful when you want to pass a state property down to a child view and allow the child view to modify it. Let's take a look at how this works. Let's extract our button into another subview. Let's call it button view. Now our button view is looking for a counter property that is defined in our parent view. So in button view, we will have a binding property that will be passed by its parent. Now the button view is looking for a parameter that is our counter. Binding properties are passed with the $sign and with the property name. Now refresh your canvas. Here the counter button view receives the counter state as a binding. This allows the button in the child view to update the state in the parent view. As you can see, whenever I press the increment, it behaves same as the one we did in the previous section. So that state property is now passed into the child view and the child view is updating that value. So in simple words, I would say that state property is used to re-render the view within its defining scope. And if you want to use it in its child views, then you would have to pass it through a binding property. Now that we have understand how state works and how binding works, next up we have a state object. State object works exactly how a state works, and the only difference is that state is for value types and state object is for reference types. And the reference type must conform to the observable object. Let me show you with an example. Let's create a class called counter model. Let's confirm the observable object. Now let's move our property to that object. So instead of having the state properties in your observable object, you need to have published properties. So in your observable object, all of your published properties will be observed for any change. So whenever these properties will be updated, your view will be re-rendered. Now let's create our state object. Refresh the canvas and we have the same program working with an observable object. So our state object is for the reference types, like for your classes, and the class must conform to the observable object. You can have other properties that are not being published and they will not be observed and the view will not re-render for those properties. So in your observable object, you have to mark all your properties with add published that you want to be observed, and that should behave like a state. So in this example, our counter model is created using state object, which ensures that the counter model instance is only created once during the view's lifecycle and persists as the view updates. Now let's talk about observed objects. This is typically used when the object is created outside the view and you need to observe its changes. So in the state object, we are creating our model here. So let's say if we need to create this object outside of the view, so in that case we will be using the observed object. For example, we need the same model in our button view. Let's create an observed object. So you can see that in our button view, we are actually not initializing our model, but we are observing its values. While in our main content view, in our state object, we are initializing our model. So the only difference between the state object and an observed object is that we do not need to initialize an observed object. It is being observed from its parent. The object is being created in its parent and is being passed to this current view, and we do not need to initialize it. We just pass its value and it's been observed. Now let's run our program and see how it behaves. So it works as expected. So now we have covered state properties, bindings, published properties, state objects, and observed objects. Lastly, let's discuss environment object. This is useful for sharing data across multiple views without explicitly passing it through the view hierarchy. To use environment object, you first need to inject the object into the environment and then use it in any child view. So let's look at an example. Embed your view into a navigation stack or a simple navigation view. So we do not need our button anymore. We have a simple navigation link, and we will move to the detail view. Let's move our buttons logic into our detail view. So the models property is missing here, and let's add it to our environment object. So our detail view has a model that is an environment object, and we haven't passed that object into our view. So in our navigation link, let's create a view. Now we have successfully created our navigation view, and in our navigation view, we have a navigation link that has a destination, our detail view. So now let's pass the environment object dot environment object. Now refresh our content view. So we have a navigation link with this title, go to detail view, and on tapping of this we have a detail counter. So you can see that we have a counter label and a button to increment its value. So whenever I press the increment button, it increments its value. So in the detail view, it's getting its model property from the environment object. Now that environment object is available in all of the child views. For example, if you want to replace the button with the button view, and we access the model through the environment object, it will work the same, and that model will be available in the button view as well. So once you enable the environment object in a view, that environment object will be available in all of the child views. So that's how the environment object actually works. Now go to the detail view and increment the value, and it works as expected. And there you have it, a comprehensive overview of data flow in SwiftUI using state, binding, state object, observed object, published, and environment object. Understanding these concepts is crucial for building responsive and efficient SwiftUI apps. If you find this video helpful, please give it a thumbs up. Also let us know in the comments if you have any questions or topics you would like us to cover in the future videos. Thanks for watching, and we'll see you in the next one.